Welcome everyone to PyRVA. Tonight we have Avi from Metabob, which is a AI tool for writing code in Python, if I understand that correctly. And he is the CTO of Metabob and joining us here tonight. As per usual on lecture nights, we have our raffle for a PyCharm license. So type pick me in either of the chat channels and it will pick up your entry, and at the end of the meeting we'll draw for a random winner and Chris May will get you the information for the license. With that's all I really have as far as announcements, so I will turn it over to Avi to tell us all about Metabob.
Hey everybody, how's it going? Nice to be here and nice to meet you. So as Brian had mentioned, we here at Metabob are an AI-based static analysis tool for helping you write code in Python. What we're doing actually is we're using AI to help you cut your debugging time in half, or at least that's the short-term goal. And so just some quick background about us and the company. We're a fairly new company. We started in earnest really at the beginning of 2019. However, a lot of that was being done through a research partnership with a couple of university researchers at Princeton through a program called NEC X, which is a subsidiary of this larger Japanese conglomerate. So me and my co-founder, we sort of got involved in that, and we were doing like different sorts of tooling or other development of different like techniques to help developers quickly identify different sorts of problems within their code base. We were using some other techniques based off code smells, but from like the customer interviews that we were doing, and as we were like approaching different development teams and everything, we really sort of started to realize that there was like a fairly significant gap in terms of what developers were using in terms of debugging their code, and the fact that these processes really haven't changed in like 50, 60 years. Like since programming was invented, people have been using the same techniques for debugging. And it's something that now, with the advent of some more like novel AI techniques, we're starting to be able to do using more automated type models, and that's what we actually like went out and tried to create. So since working with NEC and NEC Labs at Princeton, we've since spun out from that project entirely, and we started doing the normal startup rounds. We got an early funding from the Alchemist Accelerator. And then we did a long-term partnership with a company called NetApp, which does like cloud service hosting, where we sort of help their internal teams like use our product to help them save time on different parts of their application development platform. So the team started off fairly small, mostly just me, my co-founder Massimiliano. And very early on, we started bringing on some people who were very useful for us. That would be people like Ben Reeves, who is our director of AI and has like a very prestigious track record of different like cutting edge neural network techniques and like other like speech recognition and speech synthesis. We also had our wonderful UI designer, Daji, as well as like a marketing and DevOps team member, because obviously those are very essential. And we've been growing since then. We're now up to like 15 people, and we're starting to do a lot more of these sorts of events and like really bring the product out of beta into a more solid base. So what exactly are we trying to solve here? Well, debugging. So as I'm sure you're all eminently aware, like it's something that takes a lot of time to do, and it's something that you end up spending a lot of time doing instead of like making cool things. And what we want to do here is decrease the amount of time you spend not making cool things and instead looking through like a long sheet of logs to try and determine when certain things are firing or when things aren't firing, or when certain parts of your application are not responding in the way that you're expecting, going through and then adding a whole bunch of like print out statements, or going through the Python debugger and trying to put in like breakpoints or other things like that to try and make things a lot more observable, and like going through and manually trying to isolate the cause of a problem. So the existing techniques like rely very heavily on both like your ability to do like the groundwork of grinding through it, as well as more rule-based techniques that can be employed as well. But those really only work for very specific, simple problems that can be defined as a subset of simple rules. And what we're doing, or what we identified as a possible solution to this problem, is that you can actually use AI techniques, so like these numerical modeling techniques, to go through and basically identify areas that are highly correspondent to different sorts of problems by looking at like these problems arising within other applications, other programs, and identifying similar patterns within your own code base. And this helps us find like performance issues or other like process sharing or multi-threading problems, and like anything that's specific to certain platforms or certain environments that are shared across multiple different setups. So how exactly do we do this? Well, it starts obviously with the data. So what we've done basically is we've gathered a whole bunch of open source repositories, company standard practices, like common program analysis that we're doing for all the code bases as an internal step, and also like historical code reviews. And we've aggregated all of this data together, and what we're doing is we're identifying essentially which areas of the code are most likely to correspond to certain sorts of problems, and exactly what the mechanism behind that problem was, as well as what the code change that was committed is, and we can actually generate in many cases a recommendation for these sorts of problems that is insertable directly within your code base. And we've seen a lot of like growth and performance over the past year or so. I'll pause here for a little bit for some questions, if there are any. I'll wait like 5 seconds. So if nobody shouts anything out, I'll.
Did I see on the website that this is free for individuals?
Yeah. So if you have like a personal GitHub account, or are not part of an organization with too many members, it's free for you to use on like your private GitHub repos. For the organization accounts, we'll actually be releasing like a paid version of the app next year. But right now, we're just finishing up finalizing like our main flow and coming out of beta. So we're starting to open it up to more people.
Excellent.
All right. Any other questions? If not, I'll move on. All right. Yeah. So so let's go into a little bit more about how we're like different, or how our technique like differs from the existing like standard rules that most likely are employed in most CI/CD checkers. So there's like different sorts of rule-based tools. These range from everything that's simple, like linters, which are mostly for code style, and things that help uniformity within the code base, which helps you debug by just making it so that everything is a lot more understandable, because they follow common patterns and they use similar naming conventions, and everything is formatted in a way that makes sense. So that's like the most basic type of a rule-based tool. But then there's also much more sophisticated tools like Deep Source or SonarQube or SonarLint that can find more sophisticated type of problems, but overall they're still fairly simple in terms of what they identify. There's also like security checking tools like Bandit, which will find things that are very common security faults or common security oversights. And all of these function in the same way. Essentially what's happening is they are using some sort of rule-based system to look through the code base, quite often this is based on the abstract syntax tree, so they're identifying certain patterns and certain words, and you need to actually program in the patterns that it's looking for and program in the words that it's looking for in order to identify whether or not something is or is not qualifying as a bug. Unfortunately, this is prone to having either too many false positives or alternatively not properly capturing the entirety of the problem, simply because it's very difficult to make a very generic rule that can be shared across code bases for these sorts of more sophisticated issues. So what an AI solution allows you to do is basically avoid that entire step of manually defining these rules. And as well, we can better anticipate or better correlate different areas of the code base based off of where these problems are occurring and which areas are frequently changed at the same time to identify the root cause of these logical and content-based problems, and then use that information to generate explanations and recommendations based off of the historical changes to the code base that were done for those. And because we can do this implicitly as opposed to explicitly by individually defining each rule, we are more capable of finding more complex problems as long as those problems are common without necessarily having to spend the extra development effort to try and generalize out rules that are specific only to certain repositories. So that method basically allows us to find these issues in a way that's more scalable and then also more easy to keep up to date as programming patterns change and as different architectural styles come in and out of fashion. We can sort of keep up to date with that. So I'll actually pause here for a second if anybody has any questions. If not, I'll hop on. All right. So basically, our tool is the correspondence of three main features, and this is actually where I'm going to talk a little bit more about what we're doing on the technical side. So starting off, we have a topic melding system, and this is really our data pipeline overall. And what we are able to do with this is how we're able to collect the millions of pull requests that we're using from GitHub, Bitbucket, and GitLab, and basically parse through all of the documentation about these pull requests. And if you're not familiar with a pull or a merge request on an SCM provider, essentially it's a request by either an outside contributor or another team member to make some change to the code. And usually what's included in this is a reasoning behind the change, as well as a link to a particular issue that it's trying to resolve or any sort of problem that might be related. And because of this, what we can do is sort of interpolate which problems are being solved by which code changes. And that's what we're using this topic modeling system for. It's actually like a two-stage LDA model. We also use it for data cleanup. Not every code change that's being made is going to be a bug fix. People also make new features sometimes. So that's something that we need to filter out because as much as we'd like to also recommend what you should do next with your project, that isn't what we're focused on doing right now. So we need to first of all isolate the things that are bug fixes, performance improvements, or security fixes from the stuff that are documentation updates or new features, etc. And then secondarily, we need to distill down the contents of those using our LDA model into a set of discrete topics that correspond to broad genres of code changes and reasonings behind the code change. And what's important here is that we're also getting a list of words that are very specific to that code, which correspond to why that code change was made. Then, using this data, after we've categorized all of the code changes into one of these broad genres, what we can do is then feed it into our main AI model, which uses a graph attention-based neural network. So to go into a bit of detail about that, it's a fairly new technique. It was sort of created in 2017, but the paper was published in 2018. And basically what it is it uses a graph. So and by graph I mean a mathematical graph. So a network of nodes with edges. So in a way, it's the same format at which code is represented to the interpreter or the compiler that's trying to execute the code that you write. And that's represented as a graph of these nodes. So this sort of neural network uses the same structure as code would be represented in, and we can actually enrich the structure with additional semantic information from like what your documentation is like within the code, what sort of modules you're using, how your code base is calling other parts of your code base. We include also this context information to better understand how your code's connected and what's calling what, and how the sequence and order of operations is being carried out. And the attention part of this is that the model itself will learn over time as you feed in more data, essentially for each node, which other adjacent nodes are most relevant to understanding whether or not something is going to be important or not for a particular code change. And because of this, we can sort of identify these more context-dependent problems within our code base. So if there's something that's going to be non-performant, but only when it's run in a certain way, or with certain data, or in a certain like apparatus, we can sort of identify these things in a very granular way, and then also isolate them within your code base without necessarily having an issue of having additional false positives. So once we've identified like the region of code and like predicted it within your code base, which areas will need to be changed, we can then use the topics, the actual like written words behind the topics to generate like a custom bug explanation, which seeks to basically describe in the same way that the pull request describes the fix, the problem behind the code and what needed to be done to change it. As well as we can also create now, and we've recently released this as a late beta feature, to create code recommendations that are semantically viable code snippets that you can immediately implement within your code base that will resolve the problem. This is something that we're currently using like OpenAI's Codex model for. However, we're actually developing an in-house model, and it's something that's coming along fairly nicely, and we're hoping to have a much more robust technique available as soon as possible. And then finally, we also provide a lot of contextual tools, which help you like organize different projects with different collaborators, as well as better understand your code base. As you are building it out, we show you like an architectural overview, how your code base is interconnected with itself, and this can help you identify certain problems based off of how often they occur and where they're occurring. And this just overall gives you like a much better or like we hope it gives you a much better understanding about how different problems within your code base will affect other locations within your code base. All right, so I'll pause here actually for some questions if anybody has anything about our technique or what we're doing or how we're employing AI.
Oh, sorry, trying to get off of mute. Can you just walk through like a quick example of how like a dependency issue would be resolved? Like you got a package, but you forgot to install another package that's a dependency.
So for specifically things like that, we are not actually identifying problems in that domain at the moment, mainly because most tooling that people are using in Python are fairly common. in that if you're using like pip or something like Poetry or some other dependency management tool, it automatically resolves any underlying dependencies because of how the Python like package structure is built. So we found that first of all, these sorts of problems don't appear very often, and secondly, they don't show up at like a more common rate. In terms of like similar problems that we do try and resolve, these would be like misutilized modules or other things that you've imported within your code base, but are simply not, you're deploying the API in a very sub-performant way. And we would basically suggest different ways of phrasing what you're doing to be a lot more functional. That's our main like area of focus at the moment.
Got it.
All right. Are there any other questions? All right. If not, then I'll just move on. So I'll be going through a demo a little bit later, but essentially this is our like main user interface. It's fairly straightforward. As you can see on this side, it's our like visualization tool, which is what I was mentioning earlier about being able to see the overall architecture of your code base and how different problems interact with other areas. We sort of highlight everything for you immediately and make it so it's very easy to see whether or not something is or is not a problem at a glance. So we have a couple of competitors as well that you may or may not have heard of. These are just a small sample of them, which are, I guess, the most readily comparable to us because they both use AI. There's CodeGuru from Amazon, which is, I guess, more focused in their own APIs. So Amazon's APIs like Lambda or SNS or what have you, in terms of like better integrating with their systems. As well as Deepcode, which is now a part of SNCC. So if you've ever used Docker, they have like an advertisement at the bottom where whenever you build a new package, they say, hey, you should try out SNCC. We have all these like container checking tools. So Deepcode now like is part of their platform and helps identify certain more rule-based types of issues. But they actually use AI to mine these rules. So it's like a hybrid technique, basically. And in terms of like our main area of focus, which is mostly machine learning and data science, but then also as a subsidiary of that, more like application-focused Flask or Django type projects as well. Just out of like how often the code base is occurring, we do have fairly good coverage over these sorts of problems within our code bases, which like we can identify these sorts of more complicated problems that are typically ignored by other tools. All right, so there's like some overlap in terms of these other tools and ours in terms of what they cover, but that's the normal like resource leaks or concurrency issues, etc. But then on top of that, like Deepcode is more security focused, CodeGuru is more AWS focused, and we're more data science, machine learning focused. And this is just a subset of our use cases. So I'll pause here for any questions while I set the demo, and I will share that in a second. So if there's nothing else, I'll just move right on then. All right, so this is our website, metabob.com. Feel free to check it out before, during, or after this meeting. It's a fairly straightforward process to get started. When you first come here, all you need to do is click on Connect to GitHub down here. You'll be taken to our marketplace. where you can just like set up a new plan. They'll ask you for some stuff like your email, like a credit card number or whatever. But don't worry, it's completely free to open source and private repositories at the moment, so you won't have to worry about like paying anything. We'll just allow you to analyze as many repositories as you feel like, and like get started as quickly as possible. In the future, for like organization repositories, we're going to start charging, so just be aware of it. So after you set that up, basically what you'll be able to do is then log in with your GitHub or Bitbucket account here. And you'll immediately be brought to a screen similar to this, except actually it's probably more similar to this, where you'll see basically a list of repositories that you have allowed us to have access to. And you'll just need to go through and select which ones you want us to actively track. So this basically means that whenever you make a new pull request or a new commit to those repositories, or at least to the head branch of those repositories, we will automatically run the analysis and provide the results here for you to take a look at and like analyze at your leisure. So it's an automated process, essentially. So after you get it set up, it's something that you don't really have to worry about. And for every new repository you add, it's just as simple as just clicking on this gear icon and adding any additional repositories. We also have this nice dashboard. This is based off of, the data for this is based off of a subset of our categorization tool. We are like grouping them into like 7 main categories right now. But like on top of that, internally we do have quite a few of other like categories that we are thinking about adding in as well. And what we're doing is we're just assessing whether or not something's falling into one of these categories, and we can identify these issues within other code bases as well, and get the average estimated time to resolve those issues, as well as like how long certain problem resolutions might take within your own code base for certain types of problems, depending on the complexity and the length of those problems. These are only for things that aren't using the Metabob recommendations directly, but instead like the whole pipeline of resolving a problem. So identifying it and then determining the cause, thinking about and implementing the solution, and then implementing the tests for that solution, that whole process. So once the analysis has been completed for your repository, you can just hop in and click on any one of them. It's fairly straightforward. You'll be brought to a page much like this, where you'll see like a list of problems on this left-hand side, along with the code itself on this right-hand side. And basically, all you really need to do is just click around, and you'll be taken directly to the location within the code base where that problem occurred. And if you want more information about that problem, all you need to do is just click on it, and we'll provide you with some explanation about it, as well as where it's located within the code base. So from here, you can either pin or hide it. We actually do a bit of reinforcement learning based off of your feedback on this side. So if you see problems that are potentially relevant to you, but you may not want to immediately fix, you can pin them for later review. Also, everybody else who has access to this repository will be able to see which problems have been pinned or hidden. And then on top of that, you can convert them to an issue on your SCM provider. So if you're working with a team or just wanting to leave yourself a note for later, it will like include a link, the explanation, the code, all of that in like one package. So it's very easy to keep track of these as as your code base evolves. From there, you can also go through and click on the stage button here, which lets you automatically like stage a change in the code base itself, and this lets you like immediately hop to a particular thing, as well as commit it to a new branch. And from there, you can either have it run through your CI/CD process. So you might have unit tests or anything else that's configured to run. So this step will be merged in with that. And you'll automatically be able to get it with very little setup required on your part. So that's what we've just recently released. and it's something that we're fairly excited for. Moving on, you can sort of then hop over to our visualizer, where you can see like how your code base is interacting with itself. It's a little bit different from the images. We did change the color scheme slightly, but essentially you can like see an overall view of your code base and how it's structured, as well as hop around to different problems and different problem locations, and see how those problems will affect the overall code base itself. And you can go through and also view the code from here as well. And that's basically the long and short of it. Are there any? This is my final query for questions. If there's nothing else, then I have nothing else to say other than thanks for having me, and have a good rest of the day.
Question is, I am trying to get on for my repos, and it keeps giving me an error. Is that it? Just it needs time to catch up to sync with the GitHub, or?
Yeah, it does take like a couple of minutes, like 2 minutes to download to like get the stuff from GitHub, and then run the analysis. So just check back in like a couple of minutes, and you should be good to go.
All right.
I have a question for you. Does the tool allow me to specify that certain patterns should be used at least once in the code? Like, for example, you should have a strategy pattern about where the entry point is, so that we can flip it between Lambda or Flask or Fast API?
Not at the moment. We actually don't support any customizable code in terms of like specifying specific requirements or anything like that. Everything that we do right now is just through the models that we built internally. But if that's something that you are interested in, we'll definitely note it down as a suggestion.
Cool, thanks.
If there's no other questions, then that concludes the presentation. It was great talking to you guys.
Yeah, appreciate it.
And I hope you guys have a good rest of your day. And really looking forward. If you have any feedback or anything else you'd want to like send our way, feel free to reach out. I either here on Discord. I don't necessarily check this all the time, but you can also email us at our contact information on metabob.com. Axel, I think, will also provide some of it in the chat as well. We're always happy to like have feedback or anything else. If you have any other like questions or other like comments about getting it integrated for your tool set or anything else, feel free to reach out. We also do quite a few like customer interviews still to try and get how people are using the tool and where like the common pitfalls are. So if there's any like questions or feedback about that, we're more than happy to continue the conversation.
Is it possible to deploy your solution on premise with like a GitLab or a local GitLab?
We currently are not. I mean, we do support on-prem for certain enterprise companies. We have done a couple of pilot programs on-prem. At the moment, though, we're kind of focused on doing the SaaS product. We will be supporting GitLab IO, and we'll also be releasing a public version of the Metabob API that you can use to integrate with any provider, even if it's not an SCM provider, which should alleviate some of the problems when it comes to integrating with local GitLabs or local systems.
Awesome. Thank you.